This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Alright, let's solve the palindrome problem that we saw during the last hour. I saw that some of you already tried and you were pretty close to solve it, okay? You had at least some ideas about that. Actually, what was your name? Dennis. Dennis, I think I gave you the algorithm and you wrote approximately, even exactly the same code that I'm going to write, okay? So, yeah. Please sign the attendance sheet. Okay, so remember, we are not looking about a program. If I say a program, probably you will have the main and includes stuff, a using namespace, blah, blah, blah. And you're going to write the main, call a function, that function is going to solve your problem. But here I'm asking only for the function. And this is the function that we are looking for. So it should return true if the string that we are going to pass as a parameter is a palindrome, and it's going to return false if the string is not a palindrome. So then it's going to return a Boolean value. Its name is check palindrome. As a parameter, it takes a string. We are going to call it input here. I can write the code of my own, but I'm writing the code that you will have at your solutions, okay? Also, the CS201 team wrote it as well. We see that we need the length. That's why initially we're going to define a variable of integer type. It's going to be called length. And we keep the length of the input string here. So length is equal to input point length. Okay, by the way, we don't have time to repeat and to do some review about the string class, okay? You should know what the function length is doing, you should know what the function at is doing, the function find is doing, and so on, okay? You will have the videos, by the way, during the weekend, but I'm not going to repeat it, not because we don't have time. Okay. You can also figure out what the string class is doing if you didn't attend last week's recitations through concentrating and paying attention to what are we doing now, and ask questions, of course. Okay. We start from 0. And we are going to use this variable index just to iterate through indexes. That's why we are defining another variable, which is going to be called index. And initially, it's 0, because we start from 0. Now, what are we going to do? We are starting from 0 up until the middle and check whether the first and the last one are the same. The second from the right is same with the second from the left, and so on, okay? We don't have to go to the end, we go till the middle, okay? Since things are repeated. If up until now everything is okay, we don't have to check further, since we're doing the same checks. So while this index should go up until index is smaller than length divided by 2. And we are checking. What are we going to check here? If, can you help me? The name of the string is input, so you can say that this is input. If the first string from the beginning is the same as the first string from the end, then okay, try, it's okay. Or better, because we want to find whether it's a palindrome or not. If it's not a palindrome, this is A and A. Just imagine if this D here was B. So B and D are not the same. The second from the right and the second from the left are not the same. Do we have to check others? No. That's why whenever we see a mismatch of the corresponding indexes, we can return false. Okay? Otherwise, if we don't return false, when we come up until the middle, we are returning in the end true. So, how are we going to do that? If input at index, yes, is not equal to what? You can help me? Yes? Exactly, this is your formula. I mean, if you are wrong, you are wrong. I mean, it's not my fault because you gave this formula. So, at length minus 1 minus index. So, if they are not equal, what should we do? Return false. Okay. Now we saw, this is for the 0th index, for the first index, for the second, for the third. We are incrementing the index plus plus, and we are iterating the loop. If we don't return false, in the end what should we do? Return true. I mean, if these are the same, this condition here will be false, so we're not going to return false. Again, if they're the same, this is going to be false. If we iterate up until here, we don't return false. We go out from the loop, meaning that all the corresponding indexes were the same. So this condition, not equal, didn't hold. That's why we are sure that in the end we should return true. Now remember about the functions. I'm going to tell you something about the function. So this bracket is for this guy, and this is for the... Yeah, so I'm going to tell you two things. If you have only one comment, you don't have to write brackets. Okay? But if you have two or more comments, then you have to write them. So it's going to work. And this return false applies only to this if here, okay? This is going to be checked no matter if this condition is true or false. This is going to be executed, okay? So this return false is same as writing like this. But in order to be sure, for the time being, I'm encouraging you to write those brackets. In your solution, you will have them, okay? But if you have only one comment that it is associated with the if clause, you don't have to write those brackets. And this index is going to be executed no matter the value of this condition here, okay? Because this index is not associated with if. If we had brackets here, then yes, it was going to be executed. Something else also. When we write a function, we expect sometimes, very often, a value to be returned. Whenever we return a value, the function is going to be finished. Okay? So we might check, let's say the first index is A and the last index is C. So A is not equal to C. We are returning false. When we return false, we don't have to go, and we are not going and check the condition of the index and incrementing the index and again and again. If we return false, that's it. We don't continue with the function. Okay, so once this guy here is executed, whether return false or true or whatever, when we have a return, the function is finished. And we are not checking, even if we have millions of codes. Even if this while loop is going to be million of times true, we are not going to execute it. If we return false, that's it, the function is finished. You have to keep this in mind also, okay? Questions? Try to solve at your home the same example using the for syntax, the for loop. And we're going to see examples with the for loop, by the way, today. And what else? Try to figure out whether this function works if the number of characters is even. So 7 is odd. We have 7 characters here. Is it going to work if we have 8 characters? Yes or no? Try it. It's going to work. I'm telling it from now, but sometimes you have to check, okay? Because this middle stuff is kind of, because when we divide 8 by 2, we will have 4. So we are going from the 0 to the third character, 4 in all, and check the corresponding ones. But when we divide 7 by 2, we have 3. Okay, and we are saying smaller than 3, meaning 2. So we start from 0 up until 2. We don't have to check this one because it's the middle character. Okay? So it's working whether the length of the string is even or odd, it's still working. Sometimes it's not working, not this case, but in other cases you have to pay attention to this one, okay? Because you might test your input with an even number and it's working, but it's not working with odd number, or vice versa. Questions? No question. Okay, now let's go with the 9th example. And I don't know what it is about. Just let me check it. 9th example. Okay. Try to understand what we are looking here. If you want to write the code, you can write it, but you will have the solutions. So I'm going to erase this stuff. Please read the 9th question. Try to understand it, because I'm not going to explain it during the midterm exam. You should understand it yourself. So, did you understand it or not? So can you explain what we are trying to do here? Yes or no? Okay. Can someone explain me what we're trying to do here? I'll give you a clue. I'm going to explain what the program is looking. I'm going to give you the algorithm, and the algorithm means the steps we are going to use in order to solve that particular program. Okay, this is algorithm. We have something like this. We are giving inputs constantly, like let's say I'm giving 1 from my keyboard, then 3, then 7, then 8, then 11, then 15, and then -1. This -1 indicates that I'm done with inputs. I don't want to give any other input. And our job is to check the following: whether the sequence of the numbers that I've given, the consecutive numbers, 1 by 1, are in ascending order. If they are ordered, sorted. For instance, 3 is greater than 1, 7 is greater than 3, 8 is greater than 7, and so on, up until the end. We don't count this as part of the sequence, -1. So we see, yeah, they are in ascending order, so this should return true, okay? But if I give something like this, 7, 8, 5, 4, see, even if this guy is 6, but yeah, 8 is greater than 7, but 5 is not greater than 8, so this is false. This is not in ascending order, okay? How are you going to do that? By the way, these numbers are our inputs. We are giving them 1 by 1. An idea. I'm also going to tell this stuff. We are reading numbers 1 by 1. So I give 1. Initially, I give 2 numbers as an input. And I check whether it's okay with them. If it's okay with them, I'm adding another number. If it's okay for them, I'm adding another one. Okay, yes, I'm adding another one. Is it okay? Yes, I'm adding another one. Up until it's not okay, or if I enter -1. And if I enter -1, in the end I should print that cout, the sequence of the number that you gave as an input is in ascending order. Otherwise, I'm giving two numbers. Is this okay with them? Yes. Then give you another number. Is this okay? No. Since 5 is smaller than 8. Then I don't have to wait for -1. I'm just printing that, okay, this is false. The sequence of the number you entered is not in ascending order. For this stuff, you might think that, okay, we might need like millions, 1,000, or maybe 10 variables. Here we use 1, 2, 3, 4, 5, 6, 7, and here we use 6 values. But we're going to need only 2. Why? We check this one and this one, then this one and this one, this one and this one, and so on. For instance, let's say I haven't given any number up until now. Let's say this is the current value, this is the previous value, and this is a bool variable which is called is ordered. It can be called whatever. Initially I say, yeah, it's ordered, it's true. And whenever I find a sequence that's not ordered, I immediately make it false. So I'm giving numbers. Let's say I give 1 and I put 1 here. Then I give 3 and I put 3 here. And I check whether the current number is greater than 1. If this is okay, then okay, I continue giving numbers up until I get -1. So this 3, just pay attention, this 3 will be written here, and this will be empty. So I put 7 here, and I give 7 from my keyboard. Is 7 greater than 3? Yes. Continue. This 7 is here, and I give 8 from my keyboard. Is 8 greater than 7? Yes. Continue. This 8 is put here, and I give 11 from my keyboard as an input. Is the current greater than the previous number? Yes. Continue. Then 11 is put here as a previous number. I read the new number, which is the current number. Is 15 greater than 11? Yes. Then I'm reading -1. When I say -1, and is ordered up until now is not changed, then I'm just printing, I'm checking. Was this guy changed? No, it wasn't changed. I'm printing that, okay. The order, the sequence of the numbers you gave was in ascending order. Otherwise, let's see the second case. So this was the first case. This was the second case. Initially, I give 7 to the previous number. Then I'm reading 8. This is the current number. Is 8 greater than 7? Yes. This is true. Should remain true. Afterwards, I should read the number 5. That's why I put current to the previous one. And 5 comes here. Now I'm checking. Is 5 greater than 8? No. That's why I'm going to make this Boolean value to false. And whenever I see that it's false, I don't have even to give other numbers like 6, 7, or whatever. Okay? I should stop. I should not look for -1, or even I shouldn't give other numbers. Since even if I give 1 million numbers, which are in ascending order, but this 5 and this 8 and 5 are not in ascending order, so the overall list is not going to be ascending. That's why I'm going to print. No, it's not. Did you understand the algorithm? Yes or no? Okay. If you have questions about understanding the algorithm, I'm going to write the code about this one. It's going to be in main. It's going to be a program. We are not specifically asking from you to write a function. That's why writing everything in main should be sufficient from you. Well, the important stuff here is that if we see this sequence occurring in our input, we don't have to check or give other inputs. We just should stop the program. Okay. Again, did you understand this algorithm here? Because our program is going to work in this manner, as I told you, okay? If it's okay with the algorithm, of course you should include IOStream namespace std blah blah blah. I'm not going to do it right now. I'm just going to write the main function. So, in your midterm, try to write those libraries and functions and include stuff and whatever. So, as you see, I have to declare two variables. one of them is called number previous, and the other one is called number current. I have a Boolean, this guy here, variable which is called ordered. I called it isordered here. Initially, you remember I put it to be true. This is not a string. Okay. Now I'm reading the numbers one by one with C in. I have only two numbers. Just let me tell to the user that he should give some numbers. Enter the sequence of integers. So enter the sequence. And he's entering the sequence. I'm reading the first number, and it's going to be put here. So C in previous number, non-previous. Now I should check whether this is -1, since I can give -1 in the beginning. If I give -1, then it's going to be ordered. If I don't give any number, -1 means okay, I'm stopped. The list is finished. That's why I check if the number that I just gave is equal to -1. Then what? Cout list didn't start. Actually, I'm not returning anything here. So this is for this one, those brackets. Else. If the first number is not -1, then what do we have? I'm reading numbers one by one. Seen. Now I'm reading the second number, which is going to be our current number. And this while loop is the most important here. That's why I'm going to write it here. So I'm continuing here with the code. While. So while this checking works, the current number is not -1, because when I give -1, I'm finished. And what else? And if this is false, if I see that 8 and 5 occurs, I don't have to give other inputs. And if this guy is not false, meaning if it's true, and if this is true, I have to continue to check for others. Okay, so we have an AND clause. So if the newly given number is not equal to 1, and if up until now they are ordered, then continue to give other numbers. And check those numbers. The checking is done here. So if number previously, the current number, if the current number is smaller than the previous number, then what? So if this is smaller than this guy, it's false. The list is not ordered. That's why I'm writing it. So ordered is equal to false. And in the next iteration, this order is going to be false, and I don't have to check while anymore, okay? Since I found a mismatch. Otherwise, if this is not true, I mean if the current number is greater or equal to the previous number, what do? else I switch the places, so the current number becomes the previous and I read the current, okay? That's why I'm going to write it like this. That number previous is equal to the current number, and I'm reading the current number, giving new input. Scene. I'm reading the current number. Okay, so this guy is for this guy, this bracket is for this one. I'm finished with the while loop. If you have a lot of brackets, maybe you can have 10 brackets like this, you can write in comment like this, that okay, this bracket is for the while, okay? Finally, I'm writing. Now, when I finish the loop, I have either encountered -1, it should be -1 here, or the order was false. Okay, so I'm going to check it. If the order was false, if ordered, I mean if this is true, if it wasn't changed from the beginning, then I'm printing cout. The list is ordered. Otherwise, else, cout, the list is not ordered. Okay, then I have one bracket for this else here, that's why I'm writing it else, and another one for what? For the main. Okay, so this is for the main. I forgot something, and it's return 0. So I'm writing return 0. And the code is finished. Any questions? Okay. Yes? Yeah, that's why. If the current number is not equal to 1, okay, then we stop it. This is going to be false. Whatever the value of the order. But if it's not 1, but the order is false, we stop again. So we stop when we give -1 or when we see that this is not ordered. Okay?
In exam, should we give the exact answer like this?
Yeah. I mean, these samples are, if I'm not mistaken, from like 5 years or 6 years ago, something like that. Those are real midterm exams. But you will have plenty of time to do that. I mean, don't worry about that. Just think how that's why first I show you the way that you're going to solve the problem. And when you see how you solve the problem, then you just write the code about it, okay? Okay, so previous, current. If they're okay, okay. Current becomes previous, I read the current. If they're not okay, when I stop, if I have -1, or if I see that already the order is broken, I don't have to check anymore. This is it. I mean, it's easy. Don't be afraid about that. You'll have time. You'll finish it. Questions? Okay. If there are no questions, let's go with another example. Let's go with the 12th example. This is going to be a bit easier. Maybe the example that just we saw was the hardest that you will have in your exam, but you'll have time to solve it. 12th example. Okay. You remember the unsigned integer numbers? So this is the 12th one. Our job is the following. You are going to give an input for cubic meters, and you have to convert them to cubic centimeters. And you should know that 1 cubic meter is equal to 1 million cubic centimeters. Okay? But there is a problem. And what was the problem? Overflow. Yeah. You might give a number that is too big to represent with an integer, in our case, an unsigned integer. And you remember unsigned integers? What was the range of the numbers that an unsigned integer can represent? From which number to which one? You don't have to write the code, you'll have it. From? Exactly, 2 to the power 32 minus 1. The minus 1 is because we start counting from 0. So, unsigned integers have 32 bits. They are called unsigned since they don't have a sign. They can be only positive, okay? Meaning that we still use 32 bits to represent them, but they start from 0. They don't have negative numbers. From 0 up to 2 to the power of 32. You remember the number of combinations we can have with 32 bits, it's 2 to the power of 32. But since we'll start from 0, the highest number that we can represent with an unsigned integer is this one. Luckily for you, you don't have to remember. I mean, it's good to remember. Okay, I urge you to remember this stuff. But there is a library which is called climits. And in this library, you keep the ranges, the maximum values that a certain type can have. Okay? So, in our case, unsigned integer max is 2 to the power of 32 minus 1. Okay? You don't have to remember it when you use climits. Otherwise, we might ask from you to remember it. We don't know yet, okay? So our job is going to be the following. I'm going to give my input in cubic meters. Let's say I give 1,000 cubic meters. And I have to convert it to cubic centimeters, knowing that 1 cubic centimeter has 1 million cubic centimeters. Okay? Basically, 1 meter has 100 centimeters. Okay? So if I have something like this is cube. This is 1. This is 1. Length, width, height, everything is 1 meter. Basically, this is 100 centimeter, 100 centimeter. The volume of this box is 1 by 1 by 1 meter cube, and it's equivalent to 100 centimeters cube to 100 centimeters by 100 centimeters by 100 centimeters multiplied, and this is 1 million, 10 to the power of 6 centimeter cubes. Can you write the function or not? Basically, what we are going to do is to write the program, and we should give cubic meters and another function that returns the how much that the value of cubic meters that we gave corresponds to cubic centimeters. Okay, but first we have to check whether there is an overflow or not, meaning whether did we pass this value of maximum value of the value an unsigned integer can have. And remember, this value is in climits. So first I'm going to write the function, because we need to write the program, not the function, remember. the function, I'm not going to write include IOStream using namespace, blah, blah, blah. I'm just going to write this stuff, so this is important. Include climits. Here we have the limits, the ranges of the numbers. Now, the function is going to be called convert. It's void. It's taking an unsigned integer. Why unsigned? Because integer, signed integer, normal integer makes no sense, because I am not going to give, okay, I have a swimming pool in my house that has minus 1,000 meter cubes. That makes no sense, okay? So unsigned integer M3, this means that I'm giving it as meter cubes. And how I'm going to convert it? I should print it. I just print cout. This unsigned integer, meter cube, is going to be multiplied by 1 million. That's 1 0, but that's a 1 followed by 6 zeros, and that's it. So I'm converting it in this manner, not meter cube, M3. This is the name of the integer. Now I'm going to write the function. Now you might say, okay, what if there is an overflow? I'm checking for the overflow at the main part. So I have the main part here. I'm defining an unsigned variable. Which is called M3. Then I'm defining another one, unsigned integer. That's the limit that we can give to M3. And what's the limit that we can give to M3? When we are going to pass it, M3 in this function, we should be sure that an overflow is not going to happen. Okay? Exactly. But this 2 to the power of 32 is actually this guy, and it's included here. So it's equal to unsigned integer max, and this is 2 to the power of 32 minus 1, divided by 1 million. So this is the maximum value that I can give, where I can pass to this function without getting an overflow. Okay, so this is the limit. Now, I'm just prompting the user, saying to the user what he or she should do. Enter cubic meter. Limit is, and I'm printing this limit. Okay. Now again we are going to use a do-while loop, not a while do, or while loop, do-while. I'm going to continue from here. So the code continues. I have do, and I'm reading the values. Cin M3. If, and now I'm checking, if this M3 is smaller or equal to the limit, then what? I'm calling this function. So I make sure here that I don't have an overflow when I call the function. Then I call what? Convert. This is the name of the function. and I'm sending M3 as a parameter. This is it. Else, if this is not the case, you see I have here only one command, that's why I'm not going to write brackets. Else, I'm printing that cout. I'm printing that out of limit. Try again. This is for this one, and I have the while loop here, the while condition, which is if I give, at least I should execute it once, at least once. So if I give something that is smaller than the limit, okay, I have to do it again and again. So if while M3 is greater than the limit, then I have to try it again and again. Because if I give something greater than the limit, this if-else clause will prevent me to call the convert function, since I don't want to have an overflow. But if I give something that is smaller or equal to the limit, this while loop is going to be false, so I'll go outside. So at least I should give one correct input. By correct input, I mean something that is not going to make an overflow in the convert function. And this is it. I return 0. And this is for main. Questions? Is this clear? This is easy. We just check. The most important part here is to find the limit that we can give. And this is the limit. We give the input here. If the input that we gave is smaller or equal to the limit, we call the convert function. And we go outside and return 0. This is it. If the input that we give is greater than limit, I'm going to say out of limit, try again. This is going to be true, since the M3 is greater than the limit. So I'm going to execute it again and again, up until I give one true answer. An answer that makes sense, an input that is acceptable. You will have 5 minutes of pause, and we will be back. Questions? Yeah.
Are you able to use U into max? You didn't learn in the class, so...
Yeah, you didn't learn it, but you learn it now. It's easy. For integer, it's integer max.
I know, but since we didn't learn, it might create a problem. So.
You might have what?
Problem with...
If you don't want, I understand you. Then what are you going to do in order to get this number? You remember the power function? So you give 2, 32. This is 2 to the power 32. Then subtract it by 1. And you have your unsigned integer maximum number. Okay? Then limit, divide this guy by 1 million. This is it. We're going to use the CMath function, a library afterwards. Yeah?
Should we need another cout for the result?
No, because we're printing it here. Okay.